In this video, I'm going to show you how to personalize the Mifare Classic EV1 tag. So here are the requirements. You must have a Mifare Classic EV1 with a 7-byte UID tag. It does not work if you already have or if you already purchased Mifare Classic EV1 a 4-byte UID. In fact, I've already purchased 100 of this long ago, before I knew personalization can be done. So you also need a reader writer that can authenticate Mifare tags. So we know that Mifare authentication uses a proprietary protocol. So you must have the reader writer which can do the authentication. So I'll be using the ACR122U, or you can also use a PN532 board, because inside ACR122 is PN532 chip. And this personalization can be done only once. So once you apply the personalization, you cannot apply again. So this is a bit of a theory. So we know that, in fact, you read on internet, the Mifare Classic EV1 replaces the traditional Mifare Classic tags. So if you are doing any new projects on Mifare Classic, please use Mifare Classic EV1 tags. And we have seen in the previous video, these are not expensive tags as well. Now you have to read two documents. The first one is the Classic EV1. It can be 1K or a 4K documentation. Because I have got only 1K, so I referred to 1K documentation. And so I would advise you to read the entire document. So but what we are going to see in this video is present in section 10.1.1. we are going to see the various personalization commands, and I'm going to also show what is the modulation strength command. You can change the modulation strength, which I myself have never understood how this is going to affect for a developer. You have to read one more document. It's a very interesting document. It's called as a Mifare and handling of UIDs. So it's very good information about different UID sizes. So I have got both the documents open in the Acrobat Reader here. So if you look at the first one, this is the Mifare Classic EV1 1K, and you can download this from the NXP website, and this is a public document as well. The other one is the Mifare and handling of UID. This has got really interesting information for developers and in general about the theory of the UIDs and how to use, and I'll be referring this document little bit while I show you how these tags work. And if you already use the Mifare Classic tags, you must have read a similar document, and the only difference between that and this is there is the introduction of the new commands called the personalization command, which is in 10.1.1 over here. So what I'll be doing now is I will be using a different board altogether. This is the CR95HF chipset. I mentioned in my previous videos you must have a tag, or sorry, a reader writer that can authenticate the Mifare tags. This chipset is not from NXP and this does not authenticate. However, I'm going to show you, or I'm going to use this board in order to see the various activation commands. So if you use the ACR122U, you'll never get a chance to see what's happening inside, because the ACR122U or any other reader writer will automatically activate the tag and will never show you what command has been used. So I have already prepared the following tags, and if you see the documentation, I'll go there now, just show in a bit. They're called UID F0, UID F1, UID F2, UID F3. So there are four configurations you can have, and once I finish showing this, then I'm going to show you how to create these tags using the ACR122U. And keep in mind, these commands, they run only once, you can never go back. So probably now you might have to buy the pack of 100 if required. So if you go to this the classic EV1 documentation in section 10.1.1, it speaks about the personalization options, and it says the 7-byte UID variant of the MF can be operated with the 4 different functionalities denoted by UIDFN. So UIDF0, so this is the default configuration. So when you buy a new tag with 7-byte UID, and keep in mind, when you order this Mifare classic EV1 tags, please mention to the supplier you're looking for a 7-byte UID and not a 4-byte UID. Probably if you don't mention, you might end up getting a 4-byte UID. So here it says the anti-collision and selection with a double size UID. Next is UID F1. Here the anti-collision and selection with a double size UID, and or you can also use an optional a shortcut process here, which I'm going to speak more about that later. And UID F2 says, this speaks about the random ID. So you can make your card generate a random 4-byte UID. It's anti-collision selection with a single size random ID. And the last one, it's anti-collision selection with a single size UID. So here what it means is, here the last one, so you're going to start with 7-byte UID and you're going to configure it to have the 4-byte UID. And it also says the 4-byte UID is calculated out of 7-byte UID. So just you might have to read it a couple of times to understand. And if you go further down, if you look at it says here, so the default configuration at delivery is option 1. So this is option 1. So that is UID F0, which enables that's something like that. So this configuration can be changed using the personalize UID command. The execution of this command requires an authentication of sector 0. So this is the most important thing here. So if you want to change, you need a reader writer that can authenticate. And so once it has been changed, it says it is the configuration automatically locked, and the subsequent personalized ID will not execute and return the negative acknowledgement. And this is the command structure, and it says the command, the type, and the CRC. We know that the CRC is taken care of by the reader writer, so you don't have to specify the CRC. So you have to specify the command followed by the type, and the command is 40 and the type is 00 for UIDF0. In fact, by default when you buy, it is always in the UIDF0. So I'm not sure if you can buy a Mifare classic EV1 tag where you can, which is not configured at all. Don't know how that thing works. And if it's 40, it is configured as no, the way you read this, the UID F1 is, it is like you do the first anti-collision and immediately read. So this is not clearly mentioned here. However, I'll show you one more document which which makes sense. What exactly is this. And if you set the type as 20, it is going to set as a random ID, and 60 you're converting the 7 byte UID to 4 byte UID. I think that's all, that's the most important thing here. There's also information about how the anti-collision selection works, which is called sequence 1, 2, and 3. Probably I'll spend some more time on these things in my next videos. So you can see here I've connected this this is a discovery board from ST Electronics based on CR95HF RFID reader writer chip, and I have made so many videos. In fact, I was going through my own videos here, and these these videos that speaks about activation anti-collision using SRIX, and also under activation in a Mifare, not Mifare, the IS41443 type A. So if you want to know more about how this activation works, okay, you can, if you already have this board, you can see my videos. In fact, you can buy these boards. They're not that expensive, cost you probably 15 or 16 pounds to buy. And if you're going behind this RFID technologies, it's worth having a board like this. You can learn a lot of get a lot of knowledge out of this board. So I also written a software which I'm going to show you now. Now this is the software I have used in all the videos, and this software is available for you to buy from eBay. What I'm going to use this software. I'm going to first connect, and if you see, these are the tags that are supported by this software at present. And before I do that, probably you don't have to have this software or this board. You don't have to have that to personalize the Mifare EV1 tags. You don't have to. It's just for information. You just want to. I'm going to show you what is happening inside. So I'm going to choose this Mifare. You can see I don't have the Mifare tags here because this board cannot authenticate, because as I mentioned before, the cryptography algorithm called Crypto1 is I suppose the proprietary of NXP. It's not open. So I'm going to choose the Mifare Ultralight, and I'm going to show you here. And in fact, I have to spoil so many. I got so many tags with the 7-byte UID stuck, and I've got 4 tags. I've labeled here as UID F0, UID F1, and UID F2, and UID F3. In fact, UID F0 is what you get when you buy a Mifare Classic EV1 7-byte UID tag. So you don't have to personalize this tag. So I'm going to show you one at a time. And because this is just a plain PCB, I've got a paper bridge here so that I can have my hands free. So I'm going to place, as soon as you bring the tag near, it lights up. So I'm going to do what's called as the activation. Okay. If you look at here, so all the things, if we start looking from here, so the first command is the REQA, and you get the response. And then the anti-collision 1, it is CL1. Then you select 1. Then the anti-collision 2, then you select it. So because it is a 7-byte UID, there are 2 anti-collision steps. So at the end of these 2, at the end of this second anti-collision, this entire UID is visible. So I'm just going to try this again. Yeah, so I was expecting to see this one here. Now this is the UID. This is the UID of this tag. Now if you look at here, so it's 0 for, this is 7-byte UID, and in the 7-byte, the very first byte is the manufacturer ID. 04 means it's NXP, and the remaining 6 bytes are the UID. So I cannot do anything more here. I cannot read. If I try to read, I'll get an error because read needs authentication. So this is so what you have to keep in mind here is in UIDF0 there are 2 anti-collision cycles, and the UID is fixed. You can't change this UID. Okay. Next, I'm going to show you the UID1. So UID1, we have seen the documentation. Please see the documentation again. So I'm going to place that. UID1 is same as UID0. You still go through 2 anti-collisions to get the 7-byte UID. Okay, it's a 7-byte UID. So I'm going to activate. That this time I got a different UID. So it's the same thing. There's no difference between UID 1 and UID 0. However, in UID 1 you can also activate in a different method, which I have explained in this video on Mifare ultralight. So to understand this, the second part, that using a shortcut, you have to go and see the Mifare ultralight tag. I'm going to show that now. So I have just opened this Mifare ultralight documentation, and there's a nice flow chart here. And I've explained this flow chart in my videos. I just mentioned about the videos on activation using CR95HF. So here, this UID F1, the shortcut method means after the first anti-collision and after the selection here, so you don't have to do the second anti-collision. You can directly try to read the content of address 0. Now you may be wondering, reading from Mifare Classic always needs authentication. So however, this is an exception. So you can read the content of address 0 without authentication. So I'm going to repeat this again. So in the shortcut method, what the documentation says means, after the first anti-collision and selection, we have to read the address 0, and I'm going to show how that is done here. So I'm going to, that you can't activate a tag twice, so you have to either halt it or you can just take it out and put it back. So I've got the second choice is what it does. Remember the first one, you may wonder what is this ready one. In ultralight tags, there is one more shortcut. You can just do the anti-collision, you can just, after this REQA, you can just directly read the content of sector 0, or address 0. So that's what ready 1, ready 2 means, and which doesn't work in Mifare Classic EV1. So I'm going to choose this method and activate. Now look at the interesting thing that's happening here. The REQA we sent first, you got the response. Then the first anti-collision is sent, you got the response, and you have to select it. So when you select, after the selection, so I don't want I don't want to go more detail about these selection because I've got many videos on that. Look at this, read address 0. Read address 0, we have already got this data, and this is the content of the manufacturer block 0. So you can see somewhere in the manufacturer block you can see this data. So 16 bytes from here, because this is a Mifare classic, and we are reading the entire block, and each block has got 16 bytes. Now this is the content of the manufacturer block. So this is what the shortcut in UID F1 means. So next I'm going to show you this the UID F2 tag. F2, UID F2 means random ID. So in the random ID, so random ID is a very interesting concept. Now, by using random ID, we are hiding the UID of the tag. In a Mifare classic, the UID is stored in the block 0. So let's see what this random ID does. So I'm going to activate. So this error, because of the way I placed. Try again. Activate. Look at that. Now activation is done, and the entire activation has finished using only one anti-collision cycle. Now this is what a standard Mifare classic does. A standard Mifare classic with the 4-byte UID can be activated with the very first anti-collision. However, you have to notice the number. Any UID starting with 08 means this is a random ID. Now every time you place this tag into the field, you will get a different ID. Just see that this is the ending with 6D. I'm going to activate again. This time you got a different 4-byte ID. It's a different ID. That's exactly what the random ID means. So there's some interesting features, as a developer we can. Oh, this is my problem. My program error. Not expecting this.